This is Pre-Calculus, Unit 3, Lesson 6. We're looking at parent functions again. We looked at the parent functions of linear functions, y equals x, absolute value functions, y equals the absolute value of x, and what was the other one? My mind just went blank. We looked at a couple of 3 different parent functions. We're going to look at some more parent functions. We're going to look at exponential, logarithmic, power, and root functions. Okay, so you recall the concept is that parent functions can be modified through transformations, right? By adding parameters to them. But the parent function is the function that generates all the others. And the same is true for these particular ones. An exponential function is defined as y equals a to the x, where x, the variable, is in the exponent here. So the parent function here could be 2 to the x, or oftentimes is e to the x. Okay, any base multiplied or raised to the power of x, where x is the independent variable. I'm going to use 2 to the x because it's easier to understand with this particular case. And we're going to go to Desmos and look at a graph here. Okay, so let's clear out all the other stuff here, and let's graph y equals 2 to the x and look at the parts of the function here. Okay, the the y-intercept is 1, right? The y-intercept of any exponential function is 1 unless you put a multiplier in front of it to change that, right? So for example, if I say y equals 3 times 2 to the x, okay, that 3 times is going to stretch it vertically, and now it's not going through the x-intercept or the y-intercept at 1, it's going through at 3. Okay, so you can also think of this as the start value, like in y equals mx plus b, where b is the y-intercept. Here is a y-intercept right there. Okay, and look at what happens here. We start multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is, or 1 times 2 is 2. 2 times 2 is 4. There we go. 4 times 2 is 8. We're multiplying the previous one by 8. So we're constantly multiplying by 8. I can't get it to work out. The next one's going to go off the graph because 8 times 2 is 16, and so on and so forth. So it's repeated doubling. It's repeated multiplication by the number in the base. The other direction, if I go to -1, 2 to the -1 is 1/2, right? And I can't get it to lean on there. Come on, with -1. There, -1/2. And so we're dividing by 2 going to the left. And notice the shape is asymptotic. It's going to go closer and closer to 0 because we continue to divide by 2. If I continue to divide by 2 infinitely, I will never quite get to 0, but I will approach 0. But I will never cross the y-axis. Notice, by the way, that the range of the exponential function, parent function, does not include any negative values. Okay? Right. And so we can modify that. We can multiply. We already multiplied. We can do 2 to the power of, and then x plus 1, or x plus 2, that'll shift it to the left 2, right? Shift it to the left 2. If I do the plus 2 outside, that'll shift everything up 2. So those are our translations. If we want to compress it horizontally, I'll put 2 in front of it. Now it's half as wide, right? Okay. Not the same, by the way, as making it twice as tall. So 2 times 2 to the x makes it twice as tall, right? So we can transform it that way. If I put a negative in front, it flips it down, right? If I put a negative on x, it flips it to the left, right? Negative x goes down to the left. And by the way, this is also an example of exponential decay as opposed to exponential growth. It has a negative exponent. Okay? So that's the parent function for exponential functions. Logarithmic functions are the opposite or reciprocal or the inverse, not reciprocal, the inverse function of the exponential function. So if I say y equals log base 2 of x, that is the inverse of that of the function. So at each point I say 2 to what power is x? 2 to what power is x? The answer to a log is a power. And you'll notice the reflection. We've talked about inverses. Y equals x. These are inverses of each other. Log base 2 of x and 2 to the x are inverses. Okay? And of course, as you can imagine, we can transform log base 2. So it is a parent function. I can make everything twice as tall by putting a 2 in front. Right? I can make everything compressed by a factor of 2 by putting a 2, so compress it horizontally, right? I can add 2 and shift it to the left, to the x. I can add 2 to the whole function and shift it up. I can put a negative in front, and that will flip it vertically. I can put a negative on the x, and that will flip it horizontally, okay? So all of these are possible here, but the parent function is log x, right? And then power functions. Power functions are different from, and they're distinguishable. So we've talked about log functions. Y equals log base b, or in this case 2 of x. Okay. Power functions are y equals x to the n, where n is some power, right? N is some power. So we could say y equals x to the 2, or y equals x to the 3rd. This is a whole class of functions, right? Where the power is an integer, and the power has to be a whole number. We get in trouble, particularly with power. Well, yeah. The powers are typically indicated as integers. So y equals x to the 2nd. X to the 0 is a power function, which is constant. X to the 1 is a power function, which is 1. X to the 2 is a power function, which is a parabola. X to the 3rd, x to the 4th, x to the 5th, x to the 6th, x to the 7th, x to the 8th, and so on. The big takeaway here is if the power y equals x to the p. If the power is even, it does this. If the power is odd, it does this. Okay, it's up and down on one side, on the other. Okay, so that's kind of the big takeaway of power functions. And again, I can transform power functions. And the root function is the reverse of the power function. So y equals the p root of x is the power function here. And again, it's going to behave as the inverse of the power function. So y equals the square root of x, right, is the inverse of y equals x squared, but only with a domain restriction. So with even functions, we'll have to have a domain restriction. So we'll have to say x is greater than or equal to 0, and then it works, right? But what if we say it's the 3rd root, right? So y equals the cube root of x, right? Now we need no domain restriction. That is the inverse of y equals x cubed. Okay? Okay. And odd powers are a little more difficult to graph on your calculator, so or powers higher than 3. We can't go cube root. So if I want to go 4th root, I'm going to do x to the 1/4. So we start using fractional exponents. And again, that's the inverse of y equals x to the 4th, but only with a domain restriction. So x has to be greater than or equal to 0. And now it works. Okay. So even roots need a domain restriction on the original in order to be inverses. But even roots can be moved around again, twice as tall. Right? If I, by the way, if I put it twice as tall here, that is that the same as putting it here? Now the 2 is found the 4th power. That makes it half as wide. So no, it's not the same. If I go x minus 2 to the power of 1/4, it moves to the right 2. If I go add 2 to the whole thing, it shifts it up 2, and so forth. Okay? So exponential functions and logarithmic functions are inverses. Power functions and root functions are inverses as well. Okay, so hopefully that helps.